Hello everyone, welcome back, and this is me attempting maximum average subarray. And it's rated easy, and I believe it should be a short video, but let's get right into it. So mainly you're given an integer array called nums, and it has n number of elements, and it has an integer and it's also given an integer k. So we need to find a contiguous subarray, which means just connected subarray with whose length is equal to k, and we need to return the maximum average value and return that value. Okay. And our calculation error less than 10 to the power of -5, which just means 5 decimal places. Um, and yeah, so it's quite a straightforward question, which is an array is given and we need to find the average of k elements. In this case, k is 4. And this average, we find this average, take it somewhere, and we find this average, take it somewhere, and we find this average, take it somewhere, and see the largest out of that array, like that, find the largest average, and then just return that. So the brute force method of this would be to just run a for loop and say for I is equal to 0, we take the 4 elements and divide them by 4. Then I is 1, then we do another 4 and divide them by 4. Sum them again, divide them by 4. That would be the brute force method. But there is a technique which can help us speed things up and do it more computationally efficient, and that is using sliding window. So a sliding window is we take this for, we sum them just once, and then subsequently we just drop the last one and add the next one. That way we have the same effect of getting the next sum, but we only traversing through k number of items once. So like in this case, k is a small number, it's fine. But what if k was a really large number, which it could have been, like k 10 to the power of 5? And that would have been pretty intense. Like if we're going to be like for I is equal to that, k 10 to the power of 5, another 10 to the power of 5, another 10 to the power of 5, that would just be insane. So to combat that, a sliding window technique helps us by only doing that intensive k summing thing once, and subsequently we just traverse the whole thing in n time complexity. So effectively, the time complexity of sliding window would be k plus n. And that is a pretty efficient uh, algorithm, I would say. So yeah, let's get straight to coding it. I think some people visualize it better as code. So I'll keep two variables to monitor, and I'll write a for loop for I in range length nums minus k because I want to see up till 4 values. And what I'm going to do is I'm going to keep track of the delta value. I don't know, for those who took physics, delta is like you're just checking for the change. So currently, the first 4 values would have some sum, and there'll be some average for that. We just take that as the base value, which is if any other sum is equal to this, if any other average is equal to this, the change will be 0. So we are looking for something that will give us a larger average than this. So the next average could be like 1. The next average could be like -2 or something. But basically, I'm keeping this as the base value, keeping this as the base average, and checking against the rest as the delta value. Like what is the delta of the rest? So current our plus minus so plus equals to the last value, which is I'll subtract the previous one, which is nums I, and I'll be seeing, oh, I'm doing it wrong. Yep. And minus the previous value. So nums will look at I plus 4, which is this. I plus 4 is fourth index 0, 1, 2, 3, 4, this index, and it will drop the first index, which is nums I. And after that, I will do a max is equal to max current. So whatever is current delta versus whatever is initially the max. So 0 will be the initial state, right? Which is initial state, the base state, which is 0. The next set, whatever it gives, it's either in like relative to the previous one, it'll be some number. Basically, the largest sum will be the largest average. So that's the idea that I'm going for. So I'm trying to find the largest sum first. So to find the largest sum, keeping this base value, checking this. Let's say the +1, -1, some number that I'm seeing. And I'm trying to find what is the maximum delta that I'm gonna get. So maximum, and by doing this, I will get that maximum delta. And once I find the maximum delta, I can just return the value already, which is I'll first need to sum the first n k number of items. So k plus just the max, plus the max. And since I need to find the average and the denominator value stays the same, it's just divided by k. So sum of the base value, the base series plus the maximum delta that we have found, that will give us the largest sum of items, and divided by k will give us the largest average of the items. And this should work. Hopefully I didn't make any careless mistakes anywhere. So it seems to work. If anyone's wondering why is it 0000, it's just Leetcode kind of helping us format it in a certain way. Like returning this will just return like a like a decimal place, like a double value, and they're just truncating it over here because they have helped us in a way to pre-process it. But yeah, so output will be this and expected is this. It's correct. It's likewise for this. And let's hit submit, and hopefully it's all correct. So yeah, we beat 97%, and we beat 81% in terms of memory. As mentioned earlier, this sum operation will take a time complexity of k, and this operation will take technically n minus k. So it'll be k plus n minus k, which is effectively n. So this whole operation's time complexity is n. And memory-wise, we didn't allocate any new arrays. It's just a bunch of variable pointers. And so that is the benefit of it. And the reason why I'm trying to like talk more is because I want to drive home the point, which is sliding window. This was an easy question, and we here itself we're able to see how we are able to achieve superior results. But this sliding window can get a bit tricky, and in those instances, like a sliding window, like this question is not particularly sliding window, we can do it in other ways, but a sliding window helps us achieve superior results. In other questions, this can help us really, really to a great extent, and hopefully we get to explore those kind of questions in the future as well. So yeah, just take this in mind. Like one of the solutions that we can use in Leetcode is sliding window. So hope you guys enjoyed the video, and I'll see you guys in the next one. Thank you.